Hi guys, Jonathan from Structural BIM here, your Autodesk Expert Elite. And today I'm going to look at modelling up a quarter turn stairs in Advanced Steel. I'm using the latest, which is Advanced Steel 2020. I've got a little platform just with some channel beams and some grating to form my landing where my stairs is going to join on the first floor. For those of you not familiar with the Stair tool, it's on the Home tab and it's under Extended Modeling. And when you click it, it asks you on the command line sort of the definition points. So there's three different modes: start and end point, length and angle, height and angle. So I'm going to use pretty much the one I use most times, which is a start and an end point. And what I do for that is I put in some construction lines to set out my stair. I've already got a layer in my browser which sort of just sets out where I'm going to do it. So I'm doing a quarter turn, so this will involve 2 stair runs from up to the quarter turn landing area and then turn it on to the platform. To do that, I'm going to do the stair in 2 sections and then manually configure the landing section. So reset my UCS to world coordinates, look at the stair tool, and then choose my definition option. So I'm going to click enter to confirm that I'm going to pick the start and the end point. It then asks me to pick the end point. So I'm picking the point at the bottom of my stair, and then I'm picking a point up here. And notice I'm just leaving it down from the top section. That's where my newel post is going to be, and I'm going to pop that in there, and then it asks you to align the staircase. So you align it based upon the definition points. So left 0, middle is default, 2 to the right. In this case I want to put it to the right hand side. We click enter and that will launch the stair macro and pop a default staircase into my model. So it takes a little second or two because it's quite a big macro that is running. And there it pops in. I'm just going to close the dialog box, and there we get an initial staircase. So to get the stair macro up again, I select a part, right click, and I've got Advanced Joint Properties. Now within the staircase there's not quite a million options, but there are hundreds of different options for the definition on the stringers, the treads, top, bottom, landings. I'm just going to put in a folded plate tread with a flat bar stringer. So if I go on my distances, you will see that the width is grayed out, and that is usually controlled by the stair tread type. So if I first of all go to the step general tab, and first of all I want to look at the formula. So it's currently basing it on its own formula, 2 rise plus 1 going. So I'm going to tick that out and I'm going to set in my own. So I'm going to set my going of 230, and that will work out in this instance to have 9 risers. And the tread type, this is the one that's controlling the width. You'll see that it's on a grated tread, so that will look at the standard grating, and that's where the 1 meter thickness is coming from. But if I change it, and in this case I'm going to put in a tread type 7, and that will change the tread type to a folded plate with a angle connection onto the stringer. And then when I go back to distance to stringer, you will see that the width field is now. So I'm going to enter a width of 1480, and that updates the width of the stair. You'll see that the length and the height are all good, and that is the going and rise set, and this is my tread type. So first of all, it's got a bolted angle, bolted. I'm going to change that I want to run a welded bolted connection. So top part welded to the tread, and then a bolted connection there. And then for the next bit, what I usually tend to do is I'm going to switch it into wireframe like that. Go to the front view so I can just get side on to my stairs so I can see how I can configure the tread. Select it and go to Advanced Joint Properties, and then I go to my tread type. So I've got everything set. I might just change the bolts down to 16s and that will update them. They're pretty good, the angle's okay, everything's okay there, and I'm going to look at the tread dimensions. So this controls the actual individual tread, and you'll see that if we start looking at the bend and angle first of all, so if I want to put a 90-degree bend on the front, and I'm also going to put a 90-degree bend on the back, so that gets me that situation. And you'll see then I can change the back front length. I can say 75, and then the back length, if I say 125, you'll see they will now start to intersect. But if I just change that, let's say to 115, and then if we change the thread distance to 240, that's going to incorporate the thickness of the lip on both sides, so it should shift it back. So I'm now getting my lap the way that I wanted on my treads. And if we come out of that, let's have a look at it in 3D and see what we have. So we're starting to get something that looks a little bit better. So let's look at the stringers. So again, right click, advanced joint properties, and we want to change the stringer, let's say to a flat. So we go to the distance of stringer, stringer type, and then here we can choose the drop down to a flat, and we let the library calculate, and I'm thinking maybe 250 by 10. And there we go, and we have something like that. We just take a look at wireframe again. You'll now see that's sort of what we're now working with. Now again, you can adjust all these values for the positioning. You can offset the position of that stringer, but I'm going to leave it as is. And one final thing I want to look at is the landing at the top. I want to take that off. So I'm going to go to step general or the landing and tick off create front, create rear, and I'm left with that. Okay, so what I'm now going to do is use a joint copy, because the stair is an actual joint. So I'm going to use joint copy, select my stair, and again I get the same inputs for the stair. So it's enter to confirm to start and an end point. First point is going to be here, and the second point is up the top, let's say here, and I justify it to the right, and you'll see that pops the stair into position. Now one thing I have noticed, that sometimes when you do a joint copy, you'll see the way the width of the stair hasn't copied. So I'm just going to go advanced joint copy, and I'm going to just quickly adjust the tread type. So I'm going to go to 1 and then back to 7, and it should recalc the width. Then I can go to stringer and I can say 1480, and that will adjust my width, and then quickly just adjust my tread dimensions, because you can see the way there it just resets them. So that should give me that. Just have a look at the tread type. It's welded, bolted, everything's okay. So most of the things copy, it's just sometimes that width doesn't update and change. You will see here that my stair, just the definition lines I've used are actually 10mm out. Now, there's a well-known issue in advance that I just simply cannot move the staircase unless I go to wireframe and I select the structural element box. So if I just select the white box rather than the joint box, I'll just use a standard move tool and I move that 10mm. You'll see now that that will shift it, and I also do the same on the bottom. And then we go back to realistic, and we now have our staircase starting to come into fruition. So at the bottom of the staircase, I'm going to put a bottom detail. If I go to my connection vault, under miscellaneous, there is a stair anchor angle. I can make it a favorite. It'll now appear in my favorites tab. And you just select the stringer, right click. Do you want to select a reference point? In this case, no. and it will put on an angle. If I go to general, I can create a vertical profile, adjust the level. So that looks pretty good. If I want, I can bolt it both sides, but again, I'm just going to leave it. You could bolt it if you wish, but I'm just going to leave it as welded and then just use the anchor. There you can see you can select the type and then also the distances, and you can also control the angle length. So if you said something like that, but I may go with, let's say 75, 100 looks pretty good. And there we have, I may want to adjust the start distance and the distances here. So I might just go centered on. That looks pretty good. Don't bolt it on the gauge line, and I might just offset that out 50. So I've got something like that, and then because it's a joint, I can joint copy across to here. And then the only thing I need to do, because I've joint copied and the angle is on the left, I just need to adjust it so the angle is now on the right. So in this model, I've also got joint boxes turned off, but if you want to see them, I could turn them back on. You can see that's what we're dealing with. So now I want to start looking at modeling in the landing section. So I've got some construction lines where I'm going to model my stringer coming round, and I'm going to use a flat section. So just double check your UCS. In my case, it's actually okay. And I'm going to model a beam from there to there. You will see that that puts it into position, and what I want to do is just position it on the other side. So position it there. Just double check my section. It's a 250 by 10 flat, and then I also want to model from there to there. I may want to just switch the position of that and put that there, and then one across the top. And again, just make sure everything is aligned. And so once I get the three in there, it's just a case of using the miter tool. So on features, I've got miter, and I want to miter the end of the stringer to the end of there, so you can see that goes in there. If I go cut, create a weld, and then we want to do the same here. So this is a little bit trickier because we have to select the edges. It may be easier to do it in wireframe. So we get to here, and then we miter this edge against this edge, and that will miter that, and then we're going to miter this edge here against that edge, and you'll see what I mean. It can be a little bit tricky. So if I just undo that, so let's just run it again. We miter, there we go, and then we realistic, and you'll see there we get our stringer coming round. And on this side then we can go to flat. What you could try and do is use the continuous beam. So if we draw a continuous beam from here, and see how that looks if we change the section to a flat. And a 250 by 10, which is there. What you may need to do then is adjust that one. Looks okay, but I might just switch its position to be on the inside. Then this one needs a complete rotation to there, and its position needs to be mirrored, and then this one again just needs a flip to that side, and then it's the same case of using the miter tools again. So I'm going to miter this edge with this one, and then again and I always seem to get it wrong when I'm recording. So we just want to take that edge so that miters them into position, and then we can just miter that with that, and you can see we are 10 mil out on this side, so we can just shift these over 10, and then we can miter that corner to there. So you can see we're all pretty good there. We orbit that round, and now we're ready to draw the landing section. So I'm going to do the landing with some folded plate. Just for clarity, I'm going to switch this to wireframe, and I'm going to draw in a standard plate. So 2 points from, let's say, here. So to do this, I might want to just get my UCS at the correct point. So I'm going to put it on top of the stringer there, and then draw my plate from that point. You can see the plate going in, and if we draw it over to there, and we go with a 5 mil plate. So when we go into wireframe or to realistic, you will see that I've drawn this plate into position, and now what I want to do is to split it along these reference lines that I have used. So to do that, I might just go into wireframe to make it a little bit easier. So if I go to objects, you will see under the plate tools, I will have a split tool, split plate by 2 points, or split by line. So I'm going to use the line tool, select my plate, right click, and then select line 1. So it's plate, then the line. You'll see there's the first split, and then I split it again at that point, and we go into realistic, and this is what we've got. So to create the steps, I'm just going to move this plate up 150 because that's my rise, and I'm also going to move this up 300, so that gets me to this situation here. So I've now got my plates into position, and I'm now going to put in some folded lips on the front and the back. So on this section here, let's have a look. So we want to create a lip on the front, so I'm just going to rotate my UCS along its axis here. So you can see the UCS is sitting at the front of the plate, and then I'm just going to draw a little reference line, let's say down 100 here. So that just gets me a point on where I want my plate to be, and then I'm going to use my 2 point plate again, and I'm going to draw a plate from that point from there. So if we draw it from this edge here, and we draw it over to that point, that draws the plate. We have a quick look, and you'll see I've got my plate drawn into position. And then if I just look onto the side section, so let's set the UCS to 0, let's look on from the side, and let's go into wireframe. So what I want is I want this plate at the front, so I'm just going to measure a quick distance from there to there, and you'll see that it is 23. And if I just UCS to the view and move that plate 28, which includes actually just move it 23. So what we can now do with that in position, if we UCS that back to home, and we just have a look at in a shaded view just so it's a little bit clearer. So let's change that to realistic. And what I want to do is fold this plate into this one. So if you look under the plate tools, we have two folded plate options, one with position adjustment, one without. So I want it without position adjustment, and I'm going to fold that edge into that one. You will see that, you see the way it folds a lip. We've got a 10mm radius, looks pretty good. And then what I may do is just stretch the edge of that plate. You see the way you can stretch it over, but I might actually just leave that as is. Or what I could do is, if I change it to a wireframe, you can see you can delete the fold. And if I just stretch the edge of that plate over to there, then I fold it in. So without position adjustment, then I have a look at that, and that's folded that in like that, which is starting to look pretty good. If we then set the UCS on the step here, we can look at, so I'll go with a 3-point UCS on this top section from there over to here, and you'll see that my UCS is now in this section. I'll just rotate it round, so I've got my Z in that direction. And again, a similar principle, I'm just going to come down 100mm from here, just so I get a line that I can draw a 2-point plate. And I'm going to go from there, oh, that was a 1-point. We choose the 2-point option from that edge across to here. Just have a quick look on, if I reset my UCS back, just on top, the distances that I've got. So that looks pretty good. And then we just undo that back so the UCS comes back to where I want it. And I'm just going to put the UCS on the front lip again. So I will fold this in now, so I can just fold so sometimes it's easier in 2D wireframe. So if I fold this edge with this, we have a quick look. That has folded that in. And what I'm going to do is just going to orbit the stairs round so I see it in here. I again position my UCS on the edge of that step, and I go back towards here. And then you can see that the UCS is sitting on the back side, so I just need to rotate it round. So the UCS is sitting like that. And then the same principle, I'm just going to draw a little lip up, so I've got an angle to come from. So let's say we go up 75, and then it should be a 2-point plate from that point to there. And if we just have a quick look, we now have the plates overlapping, and then I just need to fold the rear of the bottom. You could, if you want, move them. So I could say, let's say, move this. So if we move this plate, let's say 10. Look at it from the left. And we just have a quick look, and you'll see there's the lapping of the plates. And then we just need to fold one into the other. So I'm going to fold this into that one with a 10mm radius again, and we're now getting, if we just orbit that round, we're now getting one folded in to the other. And then it's the same principle for up here. So again, we just set our UCS on the edge of the plate. So let me just go into wireframe so it's a little bit easier to see. Ooh. So UCS on the top of that across to there, and we just rotate on X, and let's say we come down 100 and then draw a 2-point plate again. And I'm just going to move this out 10. So that puts us to here. We just orbit that round, we have a look. And then we can fold one into the other. So if we fold there, we get our lip there, and then it's just a matter of case of orbiting that round so I can get the UCS on the edge of this plate. So UCS 3 points from there. And then rotate it along X. So we have a look. So there's what I've got. I think I need another rotation. So I've got my UCS there, and then I should be able to draw my plate up. So I'm just going to go into wireframe to draw the last lip, and I'm going to come up 75, and I'm hoping that I can draw my plate from that point. So we have a quick look at what we've got. So that looks pretty good. So we've got our plate there, and then we just need to fold these two together. So I'm going to fold 1 into 2, and there we have our section here. So we've got this coming up pretty well at the bottom. I might just want to adjust the first step. So here I can just go into my staircase to finish this off. And I might just want to adjust the step at the bottom. So if I say it's not the same as the others, you can see then I can just adjust the front length, let's say to 150, just to drop it down to there. It's a little bit different. And then if we look at the one here, same principle. And we say the step at the bottom is different, and we can adjust our tread dimensions there. And then I'm just going to put in a little newel post at this point here. So I'm just going to get my UCS, select objects, go to, let's say, a box section. I'm going to run it from there to there, let's say. And we just have a quick look. That's what I've got, and we put that in, and we're just going to change it to a square hollow section, and let's go with something what looks will be okay. So probably 100 by 5. Let's position it in the center, see how that looks there. And I'm just going to sort of manually, I may just drag that down so it sort of sits at that level. To there. I could obviously drag it up as well, so I'm just sort of just winging this a little bit. So I get that there. I may want to maybe push it 15 millimeters that way. I'm just going to set the UCS on the end of my post. I'm going to cut UCS to cut the stringer to there. I may want to just rotate the UCS round there, and then I'll cut that stringer in there. And while I'm at there, I'm just going to rotate along here, and I'm going to put a little cap plate on the bottom. So again, I could just go with a end point to end point, and let's say with an 8mm plate, and then I could copy that object, let's say up to there. So we're getting up and round, and it's just this top section here as to what we're really going to do with it. So first things first, I'll put the UCS at the grating and just rotate that around, and I'm going to cut both stringers at that section there, and I'm going to cut that one there. And then we just need to look at what we're really going to do in round this section here. So I could drag this across, so I could pull this through, which is probably what I will do. But so I'm just going to set my UCS, look at it from the front. Let's go into wireframe, and we have a look at what we need to do. So what I want to do is pull this into here. Let's have a look and see what we've got. So I need to pull it across so that it's coming past that section to here, so you get something like that, and then it's just a matter of folding possibly this or putting a lip on it here. So what we will do is just take a quick distance from there to there, and you'll see that it's 60.58. Or what I can do is just split the plate. So if I just split the plate at 2 points, I'm going to say split it at that point from there to there, and you'll see I can then take that little plate out. We just have a quick look, and we orbit that round. So I've split my plate there. I've obviously just split it on the wrong side of the lip, but not to worry. We can just go down on top again, and we just want to split this plate along that front point just there, and then I can remove that section, and we have a quick orbit around, and you'll see that's what we get. So if we also just rotate the UCS, I can draw my plate here, and I'm going to put a little lip up of, let's say, 50 millimeters, and then I can draw a 2-point plate from there. So I just need to make sure my UCS is right, and we go 2 points from here to here, and you'll see it's drawn the plate but put it back in the model, so I can just move it to where I want. So I want it at that position, and then the last thing I think I need to do is just fold one into the other. We have a little look, and that should now fold round the back, and then we just need to adjust that front step height. So I go in to my macro again, and if we look at the step bottom and tread dimension 1, and if we just say, let's say 100, and then we have a look round, we orbit that, and you'll see that we've now got that. And the final thing I need to do is just cut out around the newel. So you can see in here we just need to cut, so I'm going to go UCS view, go to my features, rectangular contour, or I can just go, yep, that one, select that, and then that will cut it there. Repeat the process for that, and then there we sort of have it. Quite a sort of off the cuff sort of way to do it. Lots of different techniques within the stairs with folded plates, and again there's hundreds of options within the stair depending on what you want. So it's just a sort of an idea of how you could do the quarter turn, and yeah, that's pretty much it. Sort of quite manual, but probably the best way to get it. Now also within this video I've not really set any model rolls or taken much into the fabrication side. I've just purely focused on the modeling side of things. So thank you very much for joining me. Join me again soon where I'll be showcasing more advanced steel skills.